This is a concept, this is concept based on electricity chapter. Electricity chapter. We will talk about a series, parallel. What is the combination of resistors? A series resistor and parallel resistors. Combination of resistance waves. Uh, Tell me, what is the sign of a resistance? Do you know? Sign of not sign, symbol of a resistor. Yeah, you know this breaker of electrons, not breaker of a current. So this is a sign of, it's not a perfect sign like that. This is a sign, not a sign. I'm again and again saying sign. It's a symbol of a resistance. You are familiar with this. So let's see what is a uh, what does a series mean and what does a parallel mean. So remember, we will take too much, not too much. Sometimes it is just mm, a resistance which is more than two or more than two. Series of resistor is just a resistance which is more than two will be connected to each other. I would like to show you. If this is a one resistance, this is one resistance, okay. Now I want to add one more resistance, one more. So just we will do like that. Now in front of us there are two resistance. Can you see this one and this another? There are two resistance. Like that you can increase the number of resistance, but remember it should be connected. Okay, it should be connected. Tail to tail, head to head, not tail to tail, head to tail. Okay. If you are considering this a head and this a tail, so head of this second resistance will be connected to tail of the first resistance. Okay, and it will be continued. This will be continued. Now number of resistance are three. Remember, it can go in a straight direction. It can go downward as well, like that. It can go like that. This is known as a series. This one, two, three, four, five, six, seven, eight. There are eight resistors. Eight resistors. You can imagine. Remember, there should not be joint view. So it was about a series. Now, what about a parallel resistance? So it is also resistance, but here you will observe arrangement of resistance. Arrangement of resistance. You have seen arrangement of resistance as a series. Now let's see arrangement of resistance as a parallel. Now let's say this is one. Here this is wire, and in this wire current is flowing. This is known as a joint. This one, and this is second, and this is third. This is third, and it is a continuum. What is happening over here? There are three resistance. Even you can see this one resistance, this is second, and this is third resistance. Number of resistance in this side are 3. But you can also observe that arrangement of this is not same as it is. Both are not same in arrangement. So let's visualize it. Here this is wire, and inside this wire electrons are working, current is flowing. Remember, when electrons will be working, then some electrons will go in this side, and some electrons will go in this resistance, and some electrons will go in this resistance. So to till here, when when electrons will reach over here, then here all the electrons will be divided into three, in this and in this and in this. This is what will happen. This is what will happen. For example, we have 6 electrons, let's say minus A, then minus A, then minus A, and this minus A, and this minus A. 6 electrons. 2 electrons are going in this. 6 electrons were traveling in this inside this wire. When this 6 electrons reached here, now all this 6 electrons, two of this 6 electrons went in this, and 2 in this, and 2 in this. But when all this 6 will reach over here, then in this will come how much? 6 electrons. 6 electrons. Here you are observing division of electrons. Division of electrons. Okay. Division of electron. Now question is how to calculate this resistance and this resistance. Remember, there are two formulas. So for this formula is just total resistance R1 plus R2 plus R3. So here we have how much? Let's say we have 5 resistors. So we will write till the 5. We will write till the 5. R1, R2, R3, R4, R5. No, till the 5. This formula will give you total resistance. Now come in this. So this is parallel. So 1 upon. So formula would be what? 1 upon this parallel resistance upon 1 upon R1 plus 1 upon R2 plus 1 upon R3. We have 3 resistance. This. So how much? What is the resistance over here? We will put over here. Resistance of this we will put over here, and resistance of this we will put over here. Here we are adding. Okay, we are adding. We will get a S series. We will get from this S series. Clear? Clear? So this is series and this is a parallel. We have seen formula for series resistance, and we have seen formula for parallel resistance. Now In upcoming question, you will see a combination of series and parallel. Combination of a series and parallel. We have some question based on combination of a series and parallel. Don't worry. So, what is this combination of a series and parallel? Let me explain. Let me explain. Just have a look over it. Yeah, combination of a series. Let's say this is one, and then from here it's a joint like that. Then over here, okay. Inside this we have two, and then it is a continuum. This side we don't have a resistance. It is a combination of this figure is a combination of a series and parallel. Let's visualize. I will visualize it. Don't worry. Here, if this is one, and this one, this is second, this is third. This is three resistance is becoming a series. But when it will come this this and this three are parallel. These three are parallel. But hold on. First of all, we will solve this because of it is giving you series. If this is a 2 ohm, this is a 2 ohm, and this is a 3 ohm. Let's say this resistance is a 2 ohm and this resistance is a 3 ohm. So first of all, we will solve this. After solving this, we will get to 5 ohm. This complete is a 5 ohm. Okay. And now we have this parallel, this and this and this. So with the help of this formula, we will find this sum of this and this and this. But with the help of this, let's say if this is a 5 and this is a 5 also, not 5, it's a 4. Okay, this is a 4. This is 4 and it's a 2 ohm. 2 ohm. Okay, so we now it's a 5 and it is giving you this will give you how much? 1 upon 4 plus 1 upon 4. Okay, 1 upon 4 plus 1 upon 4 and one more 1 upon 5 this. So LCM of 4 comma 4 comma 5 will give you 2 to the then 2 1 5 5 to the 10 10 to the 20. This is 20 5 for the 5 5 and then 4. So this is giving you it's giving you how much? 10 14 upon 20. After solving this, you will get some value, 0 point something. 0 point something something. So remember, after solving this parallel series, then add this with this, you will get a total resistance. Total resistance. So one by one we will solve. First of all, you see that it is giving you a option to solve this by using this series formula. Then after solving this, you have this series, this parallel parallel resistance. After solving this, add this and this, you will get total resistance. Clear? Now let's take a question based on this concept. Based on this concept, remember this will be known as a series resistance. This will be known as a parallel resistance. This will be known as a combination of series and parallel. In this, you are observing this is series and this is parallel. This is a parallel to this. Yeah, that's why we are saying it's a combination of a series. Now, okay, brother. Let's take a picture. Hmm. Question. It's a complication. Here you will use your brain because it's not a very simple as you're thinking. It's not that much simple that I think. How can three resistors, each of resistance 3 ohm, be connected to give a total resistance of this. This is a total resistance. Total resistance is how much? 4.5 ohm, and another is a 2 ohm. So how to combine all the resistance? And remember, resistance should be 3 ohm, not 2 ohm, not 4 ohm. Okay. So how to connect all this 3 ohm resistance so that at the end we can give this total 4.5 ohm. It's your choice if you want to combine, if you want to connect all the resistance of 3 ohm in series way, then yeah, you can do like that. If by doing like that, your answer is your total resistance is coming 4.5, then okay, this is your final answer. But you will not observe like that. Yeah, we can see. Let's solve first of all this 4.5. You want to start with a series, yeah, with a series resistor. Okay, even I will start also. So if we take how much? Three resistors. Three resistors. Remember, three resistors. Not 4, not 5, not 6. And resistance is 3 ohm. So 3 ohm, how much time? 3 times. So this is a total resistance. 3 ohm plus 3 ohm. Now you can see it is giving you 9 ohm. It's not equal to 4.5 ohm. And you can say that yes, if we do like that, then we will not get a 4.5 ohm. Now next method we have parallel is 1 upon Rp. So 1 upon 3 ohm, 1 upon 3 plus 1 upon 3, 1 upon 3 plus 1 upon 3. What do you think? Will you get 4.5 if you use this parallel resistance? Let's see 1 upon RT. This is equal LCM of 3 will give you 3, and here it is nothing but 1 1 1, 3 upon 3, it is equal to 1. It's not of 4.5. So here also you will say, your heart will say that yes, no, it is not coming 4.5. What else method should we use over? So one more formula we have, which is a combination of a series and parallel. I think so we have faith on this combination of a series and parallel. Let's use this. It is not giving you 4.5. No. Figure of this will be what? Just like 1, this is 3 ohm, and another, this is again 3 ohm, then again this is 3 ohm. But it is not equal to 4.5 ohm. Yeah. Now, figure of this, diagram of this will be how much? Like that. This is joint, and we have 3 resistors. So this one, okay, then this is second, okay, this is third, okay, this is third. There are 3 resistors. In this 3 resistors, each resistors have 3 ohm resistance. Okay, this is 3 ohm, this is 3 ohm, and this is 3 ohm. But this is also not giving us 4.5. This is also not giving us 4.5. So that's why now let's see combination of a series and parallel. What if we take this 3 ohm, okay, this 3 ohm and 2 parallel, this one and this one, okay, in this side there is no resistor. This is 3 ohm and this is also 3 ohm and this is also 3 ohm. Will it give us 4.5? Let's see. First is a series and these two are parallel. So I think 1 upon RT will give 1 upon 3 plus 1 upon 3. Yeah. So this is giving you nothing but 2 upon 3. And it is becoming RT is equal to 3 upon 2. 3 upon 2. And it's nothing but just 0.5. Not 0.5. 1.5. 1.5. This parallel is coming nothing but 1.5, and we have this 3. So sum of this series and parallel is giving us 4.5. 3 plus 1.5 is becoming how much? 4.5. So finally we can say if we do like that, then it will not give us a 4.5 ohm. If we use this parallel series, then it will also not give us this parallel resistance. And if we use this combination of a series and a parallel resistance, Yeah, then it is giving you 4.5 total 4.5 resistance. Now what about this? What about this? You can see logics over here. If I don't do, if I don't do this, I don't show you this two things, then in your mind would be coming two or three points which will be disturbing you. That's why I thought I should show this two things so that you can get clarity. Now you have clarity. That is this. If we do series, then it is not giving this much. If you do this parallel, then it is not giving us 4.5. Now we used this as, then it gave us 4.5. Now let's see 2 ohm. 2 ohm. Hmm. 2 ohm. If we take this one, okay, this, it is not giving you. It is becoming how much? 9. So it's not possible from series. Okay. Now this, it will also not give us. Uh, it provides 1. Yeah. So that's why this will be also not possible. If we find this 2 ohm total from this panel, then it will not provide us 2 ohm. So next is what? Series, combination of a series and panel. But we will have to arrange logically. I think this, okay, then this, okay, and here 1. Will it provide 2? Tell me, will it provide 2? Let's see. This is a 3, and this is also 3. This is also 3. It is becoming 6 ohm. Okay, 6 ohm. So this is a 6 ohm, and it's a 3 ohm. Now this is a parallel. It's a parallel. So you can say 1 upon RT is equal to 1 upon R1 plus 1 upon R2. So 1 upon RT is equal to 1 upon R1. R1 is 3 ohm. 3 plus 1 upon 6. So it's nothing but just 3 comma 6. 3 2 3s are 6 3. So 3 2s are 6. 3 2s are 6. 3 2s are 6. Then 6 1s are 6. Okay. 3 upon 6. 1 upon 2. And this is nothing but RT is equal to 2. Yeah, you can see. It is giving you how much? 2. So it became possible when we arranged this 3 resistor in this way. Then it became possible to bring 2 ohm. You can see 2 ohm. Yeah. Is it making sense or not? Yes, it's making sense. Now I would like to write next question. Just have a look. Next question. Next question over here. Read this question. Yeah, it's a complete figure. Look at only. The figure is given by the question. We don't need to draw this figure. If in figure R1 is a 10 resistance, 10 ohm, and R2 is a 40, and R3 is a 30, and R4 is a 20, then R5 is a 60. All these are resistance in different resistors. And a 12 volt battery is connected to the arrangement. In this arrangement, you can see connection of battery. Where is battery? This is battery, and voltage of this battery is a 12 volt. Okay, 12 volt. This is a switch. It is a on. This is a on mode. It is a in on mode. This is our ammeter. It's a device to measure current, and we don't have a voltmeter device. You are familiar with this ammeter device. It is a device to measure current, and current what direction of a current is like that. It starts from positive terminal and it ends till the negative terminal of the battery. Okay. And electrons travel from negative terminal of the battery and it ends until the positive terminal of the battery. Okay. Till here we are crystal clear about it. Now next thing, it is saying if this is the arrangement which is given you. Now find the total resistance, then find the total current which is flowing inside the wire. So how to calculate? Question is how to calculate. We can find these two things. It's not difficult. Let's find this total resistance. After finding total resistance, you will be able to calculate the total current because total resistance is not given. That's why. Okay. Now you can see, analyze this. All the resistance are parallel. Yeah, all the resistance are parallel to each other. In that case, 1 upon RT will be nothing but 1 upon 10 plus 1 upon 20 plus 1 upon 30, then 1 upon 40, then 1 upon 60. Okay, all these are resistance in resistance. Okay, now let's simplify this. After simplifying this, you will get total resistance. Total resistance that are present in this arrangement. Okay. So LCM of this 10, 20, 30, 40, 60 should be how much? Let's see. 10, 20, 30, 40, 60. 2 5s are, 2 10s are, 15 2s are, 20 2s are, and 30 2s are. Next we have 5 as it, 5, then 15, then 10, then 15. Okay, again 2, 5 as it, 5 as it, then 15 as it, 5 2s are, then 15 as it. Now 3, 5 as it, 5 as it, 3 5s are, 5 as it, 3 5s are. Now 5, 5 3s are, 15, 15 2s are, 30, 30 2s are 60, 60 2s are 120, 120. It's nothing but just 120. You can see 5 3s are 15, 52s are 30, 32s are 60, and 62s are 120. Okay, we can erase this LCM part. Now this over here in numerator will come how much? 12, because 12 tens are 120. Okay, then 6 2s are 12, so here it will come nothing but 6, only 6. 4 3s are 12, this will come 4. Then next we have 4 3s are, so 3, then we have 2. Okay, then 2, 1 upon RT. You can see this 10 and this 5, 10 20 25 27, 27 upon 120. It's happy, it's happy. You can see 9 3s are 27 and 4 3s are 4 3s are 4 3s are 12. 4 3s are 12. Now RT will become nothing but just 40 upon 9, 14 upon 9. After simplifying this, you will get almost 40, and then 4. It's nothing but 4.4. RT is nothing but 4.4, something like that. So total resistance is 4 point something. If you do like that, then it will give you wrong answer. It will provide a wrong answer. Why? Reason is that you added all this with this, and here this is where you are we people are wrong. We don't need to add this with this, because it's not valid in this electricity chapter. This is separate and this is separate. We will add this separately, this is separately. Okay, so let's do. You have seen, if we add this with this, then it will provide wrong answer. Okay, it will provide wrong answer. Now for this 1 upon RT is equal to 1 upon 10 plus 1 upon 40. So 10 40 is nothing but just 2 5s are 10, 5, then 5 to the 10, 10 to the 20, 20 to the 20 to the 40. So this is 40. 10 4s are and 1. It's a 5 upon 40. 5 upon 40. So 8 5s are 40. So RT came for this. It is nothing but just 8. Okay. Now what about this? What about this? This was one. RT 1 upon 30. 1 upon 30 plus 1 upon 20 plus 1 upon 60. Now let's see what will it provide. So here we have 30, 20, 60. 15 to the 10 to the 30 to the 5 to the 15 to the 3 5s are and 5 1s are. 5 3s are 15, 15 to the 30, 30 to the 60. It's a 60. 3 to the 6, 3 to the 6. Okay. 2 to the 4. So 2 3 the 6. 6 1 the 6. Clear? It's giving you how much? 6 upon 10. 6 upon 60. 6 10s are 60. 1 upon 10. So finally you got how much? RT upon 10. RT upon 10. Now this became series. After this became series. RT is a series with this. So this and this will be series now. So RT is what? How much? 8 plus 10. This is nothing but 18 ohm. So total resistance is how much? 18. Okay, total resistance. That is how you will find. Okay, you will find. So total resistance came 18, and question is saying what is total current which is flowing inside this wire. So for I, we know that V is equal to IR. V is equal to IR. V is equal to IR. So from this formula we can get another formula which is nothing but just V upon R. I is equal to V upon R. So we have V. This V is 12 volt and R is how much? 18 ohm. So 12 upon 18. 3 4s are and 6 3s are. 2 2s are and 3 2s are. So I came 2 upon 3. It's nothing but I think 0 point something. Even you can see 0 point then 6 3 is 18. 0.6. 0.6. This is it. current follow. It's not electrons. So our I came as a 0.66 ampere. This is a unit of A is the SI unit of current, and here ohm is the SI unit of a resistance. Remember, volt is a SI unit of voltage. So finally, our answer is over here. This is a complete answer. I is this is total current flowing in this arrangement, and this it's a total resistance which is in this arrangement, which is present in this arrangement. Just have a look. Let me write next thing. Now next concept. Next concept is division in this is our next concept. Division of a current, division of a I and a V or V in series or in parallel. There is one little bit in twist in this. Now first let's say division of current, division of current. This is one resistance, then another, then another. All these are resistance in series. Now tell me, what is happening over here? This will remain same in series. Let's say this is a 2. In this resistor, the resistance is a 2 ohm. Okay, 2 ohm, and in this 3 ohm, and this is giving you 2 ohm. Okay. Now this is 2 ohm, this is 3 ohm, this is 2. All this total is how much? 7 ohm. So it is telling you that this is 7 ohm will be in this series. In this series. But this is one resistor. Okay. Yeah. Now look at what. Resistance in parallel. Resistance in parallel. So remember here we are understanding about the division of a current. In this current will remain same. Okay. In this current, if a current over here is let's say 5 ampere, 5 ampere here. So after passing this 3 resistors, here will come how much? 5 ampere. 5 ampere. This is what will happen. So 5 ampere will go in this resistor. After passing this, 5 ampere will come in this. After passing this, 5 ampere will come in this. This is what will happen. But in parallel, if a 5 ampere is over here, when this 5 ampere will reach over here at this joint, then this 5 ampere will be divided into 3 parts. So some ampere will go in this, some in this resistor, and some in this resistor. This is what will happen if arrangement of resistance is in parallel. Then, so what is happening over here? Here current is being divided into parts, and here current is the same. In this current is the same, but in this parallel current is being divided. So you can say what I divides in parallel. So here you will say I divides in parallel. Clear? I think this spelling perhaps this parallel. I divides in parallel. So here current is being divided in this parallel. Now here I remains in series. Okay. When I will come in this resistor, then here 5 ampere will be in this. When this current will come in this next resistor, then here you will observe 5 ampere. But in this here, if this is current is a 5 ampere, you will not observe that 5 ampere is in this resistor. No, some will go in this. Let's just say 1 in this, 2 in this, and 2 in this. This is what will happen. Okay. So remember, I will remain in series and I will divide in parallel. Okay. Now, what about the division of voltage in series and parallel? We have seen this in the discussion of a division of voltage in series and parallel. Just opposite of this, we will see in division of a voltage. In division of voltage. Okay, so let me write this. I remains in series. I remains in series. Now, here we have 3 resistors. This, okay. This is a battery. Voltage how much? 12 volt. 12 volt. Now remember, I said you, whatever we studied in this, whatever we explained in this, opposite of this. For example, we are saying I remains in series, but in this you will observe that volt is dividing in series. and volt remains in parallel. This is what you will observe. So here remember, if it is providing, this battery is providing 12 volt, okay, 12 volt. So in this is in series. It is an arrangement in series. So remember, if this is 12, so this will be how much? I think it will be 12. So 4 this will be 4 and this will be 4. This will be 4. Are you understanding? B1, B2, B3. That is what will happen. Clear? Now, what if we have this parallel? There are 3 resistors which are in parallel. So remember, division of voltage in parallel will be same. This is 12, so 12 volt will go in this. This will be also be. This will be also be. 12 volt will be applied in this resistor as well as in this resistor as well as in this resistor. If you talk about this, then you will not say that here is a 4 voltage. No, here will be 12 voltage. Clear? So what are you observing? V divides in series. This is the first point. Next point, V remains in parallel. Clear? In parallel. Clear? This was another next concept. You can see here V is a dividing in series, and in this V is the same in this resistor. V is also same in this resistor. 12 voltage is also present in this resistor. It will not be present here. Volt will repel. Volt will apply force on resistance. Okay, on not on resistance, on electrons, so that electrons can move. Electrons will move when there will be voltage. There will be voltage. Then electrons will move. Okay, if a voltage is increasing, then you will see a speed of electrons. Then a speed of electrons will increase. What are you observing? If a voltage is being increased, then electrons will also increase. This is what will happen. If a voltage is decreasing, then a speed of electrons will also decrease. Okay. This was perhaps I would say it was a best concept. This cannot be ignored. Now let's take a question based on this. Question based on this. How many 126 ohm resistors this is our complete question. Uh, remember, this question is based on this concept. Okay. So what is given? How many this much resistors in parallel are required to carry 5 ampere on a this much voltage line. So how much? What will be number of resistors which will carry this much ampere and should be this much resistance on this much voltage. So what are number of resistors? This is what the question is asking. Tell me. So given is what? Solve this. Voltage given which is 220 and I is given which is 5 ampere. Resistance is given which is 120. 120. Oh. Now tell me what is the number of resistors? Okay. What is the number of resistors? And remember, this is a hint. It is telling that resistors should be in parallel. How? It will look like that. Then again. Okay. Then again. So where to stop? It's a question. Where to stop? It can be 2 resistor, it can be 4 resistor, 10 resistor, 16 resistor. But exact number of resistor is what? Okay, is a what? So here, this is parallel. Okay, here 1 upon. So we know that this is R1. And here it is nothing but just number n times. It is going n times. So 1 upon Rp is equal to, we will represent this 1 as a n so that we can represent number of resistors. Okay, number of resistors. And here R1 is how much? 176 ohm. So finally you are getting Rp is given or not? So RT is not given. This RT is not given, but it doesn't mean that you will not be able to find RT. You can find RT with this formula. V is equal to IR. V is equal to IR. So V is nothing but just 220, and I is how much? 5, and R we are going to find this. So 5 for the, and then again 5 for the. So our total resistance came how much? 44. So 1 upon 44 is equal to n upon 176. This n will give you number of resistors. Okay, this n will give you number of resistors. Let's simplify this. So 44n is equal to 126. 126 upon 44. After simplifying this, you will get a number of resistors. So look at over here. 22 to the 44, and 88 to the 2 at the 16, 1, 2 adjust 16 and 120. So 88 twos are. Now 22 fours are. So n came 4. So here number of resistors are how much? This 4. Number of resistors is 4. Okay. This will be how much? This will have 126 ohm, and this 126 ohm, this 126 ohm, this 126 ohm. Okay, these are 4 resistors, and this it's our answer. How many this much resistance in parallel are required to carry 5 ampere on a 220 watt?